Hey, Moez, I think we're good to go. We're about 95% in total attendance. Are you okay to get started?
Yep.
Okay, perfect, cool. Hello, everyone. Thank you so much for attending this bonus workshop. My name is Faraz. I'm one of the main organizers at MLOps as well as TMLS. I just want to quickly share that you all would have received an email from Hopin yesterday that actually contains your link to the actual conference that is going to begin tomorrow at 9 a.m. If you have not received that link, or if you're not able to find it, please check in your junk mail. We will also be sending a reminder later today in the afternoon. Plus, there's going to be another reminder being sent later about 9 p.m. as well too. So, in case if you still haven't received the link, please definitely reach out. Either on the website, or you can email me directly at Faraz at tronamachineLearning.com. I'll also put my email address in the chat. And I hope that you all have a wonderful workshop, and I'll hand it over to you, Moez.
Thank you. Just a confirmation, you can see my screen on presentation mode?
Yes, yeah.
All right. Okay. Good afternoon, everyone. Thank you for joining us today here in this workshop. A little bit about myself. I'm an analytics leader, and I lead technical teams at PwC with respect to analytics project, and I'm a passionate data scientist by night. I'm a open source contributor, very active contributor in different communities. And very recently, I have open source a project called PyCaret, which is a machine learning library in Python, and that's what we're going to talk about today. By background, I am a chartered accountant, so my background is more towards financial reporting and analytics side. That's what I've worked in my entire career, mostly in public health. And I have lived and worked in 4 different countries, and I've done almost the same thing. But for last 2 years, my interest is more towards the machine learning side, and not necessarily the the hardcore technical, but more about integration of machine learning and how we can drive value in business using machine learning. I'm currently based in Toronto, very active on LinkedIn, and also a very active writer on Medium. So if you would like to follow me, the links are there in this slide. Some important links for today's session and in general about PyCaret. So our website, GitHub, LinkedIn, YouTube, Medium, and we have a lot of tutorials on our website, a lot of short video tutorials, bite-sized tutorials, a lot of articles. So in case you're interested to learn more about PyCaret or use it at your work or school, these links would help you to learn more about PyCaret. And today's presentation and demo, we have 4 demos, and we'll see if we can cover all of them, but not the demos are uploaded on, and this presentation is also uploaded on this link, github.com/pycaret/mlops2020. You can clone this repository to get the demos, and you can follow the hashtag PyCaret on LinkedIn and Twitter if you'd like to follow PyCaret. There are a bunch of resources on Medium, and as you can see, every week there is a deployment tutorial that we show, mostly for beginners. And last week we covered deployment on AWS Fargate, and before that we have done deployment, machine learning pipeline deployment in Google Kubernetes Engine, and then also Microsoft Azure. So I will leave the slides here. It has many tutorials and links if you would like to learn. And with that, let's get started. So in today's session, I'm gonna talk a little bit, first 10 minutes about PyCaret, a story behind it. And then we have demos for about 30-35 minutes. If you'd like to follow along, you can clone this repository, or what you can also do, if you don't want to do it on your local computer, you can use the notebooks on Google Colab. You just have to go to this link, pycaret.org/demo. And then there's a link for Google Colab notebooks. So if you'd like to follow that. In order to work with PyCaret, you need to install PyCaret on your local machine. with pip install PyCaret, it takes 5 to 10 minutes. So if you plan to follow along the demo, it's a good idea to open up your Anaconda prompt or Jupyter notebook and just type pip install PyCaret to install it. All right, let's get started. Okay, so this is the machine learning development lifecycle diagram that most of you have seen many times in different shapes and different sizes. We're not gonna talk about the entire pipeline, which basically starts with gathering data, cleaning ETL process, EDA, training machine learning, and then deploying. What we're gonna do today is zoom into this part of training model. So we'll see the granular life cycle. So this diagram is the overall project life cycle of machine learning, but I'm gonna talk about what is inside this training part, which is still quite a lot. Okay, so this is the granular life cycle of a typical supervised machine learning experiment like classification or regression. It starts with a business problem. So assuming if you're training the model, this section here, business problem and identification and defining the objective has already happened before, it's most likely, but I have put them here for the purpose of completeness only. So it starts with defining business, converting into a machine learning problem, collecting data, analyzing, right? But when it comes to training, the process starts from splitting your data set into train and test, or at a large level, design a validation environment, cross-validation or anything else that you want to use based on your data. You have to handle different data types because the techniques you apply in machine learning for categorical or numerical variables are different. So for example, in imputing missing values, you handle numeric and categorical data differently, right? And then you do encodings, scaling, transformations, feature engineering, feature interaction, and zillion other things. There's not enough space on the screen to put, but you do so many other things. And then finally, you start training the model, and you set your cross-validation strategy and start by training a model, most likely a simpler model like linear regression or logistic regression, and then you track the performance. Then you enter the loop of hyper-tuning, of tuning hyperparameters of those models. And then you keep building models and models. You ensemble it, you tune it, you stack it, you blend it for whatever reason. Sometimes you want to do it for inferences, or you want to use that model to generate prediction in production environment. In either case, it's the iteration before you actually arrive to a final model that you would use for deployment, either in production environment, you'd use to do some kind of analysis. So for example, you would use that model to generate the Shapley values or determine model agnostics for some kind of business decision, right? The point here is it's an iterative cycle, and it's not only about choosing a model like a linear regression, support vector machine, random forest. This is also about, if you see all these boxes on the screen, each of these boxes had couple of options, right? You can do there are a couple of methods for missing value imputation. There are a couple of methods for feature engineering. So if you're creating polynomial or trigonometry features, you could create it with a degree of 3, degree of 4, degree of 6. So you can do multiple times. So there's a lot of combinations that you can do. So the problem is it's iterative. You have to repeat it many times, right? And it's not very easy process. So the challenge is machine learning is an iterative process, and it takes a lot of time. And most of the time, it's about, not most of the time, I would say almost all the times, it's about asking right questions in order to get a good outcome, right? So the questions are important, not necessarily the answers, but it's very important that your data science team ask the right question with business so that everybody's on the same page and we know what is the value of this and what are we solving. Now, in order to do that, you have to remain very focused, assuming you are a citizen data scientist or a pseudo business data scientist kind of role. You're not necessarily a computer science genius. So you want to be able to avoid the difficulties that goes behind the scene under the hood and just do your thing and use tools like software, like you would use Microsoft Office or like you would use any other tool to achieve your purpose, right? Because at the end of the day, even machine learning is not the end. It's a means to the end, but it's not the end, right? So you should be able to use it as a software. Now, not being offensive with any current tools in the ecosystem, but current tools generally are not business friendly, right? There's a long standing tradition that people into data science are coming from computer science background or any quantitative statistics field, stuff like that. But that thing is changing, right? With in last 2 3 years, we have seen how companies have restructured their data science teams, and now they have business oriented data science teams. So the ecosystem isn't changing with that, right? The tools are still difficult to use. If you ask from somebody who's not coming from a computer science background, it's not the easiest thing in the world. And we have made assumptions that X package or Y package is very easy. It cannot get simpler than that. But the problem is we didn't took into account the audience that is now coming into this field, right? Which is mostly from domain or business expertise. Okay, so here comes the PyCaret, and the way it started is I was finishing up my master's program last year in a university here at Toronto, and it was a management program in analytics. And there what I experienced is about 70 to 80% of the people coming into this field, they do not have any computer science background. And what I've seen is it's extremely hard to encourage those people to do something by themselves, because they almost think like there's a separation between business and data science role. But where we are going with this is it's becoming kind of one function, right? So data science is broadly a culture. It's not just one department. So in order to encourage those people who are not coming from computer science background, PyCaret is an alternate low-code machine learning library in Python that aims to reduce cycle time from hypothesis to insights. Now, just these three things I'd like to talk about PyCaret. If you ask me in 3 words, it would be it's a very easy to use library. It's a productivity tool. So just because it's targeting a beginner or somebody not coming from computer science background doesn't mean it's basic. Because I think data scientist myself at my work, I would use this because this is like a productivity tool for me. This is like automation tool for me, right? So even if you're an experienced data scientist, I think PyCaret would come definitely handy to you in your work, and it's a business ready tool, and we will see that in demo. And difference of use. So this is one little experiment that we have done. On your x-axis, these are the stages of machine learning arranged sequentially. So you would see EDA, pre-processing, multiple model building, hyperparameter tuning, and the blue line is the lines of code you would write in a base library. In this case, the base library is scikit-learn, and red line is the line of code cumulative line of code that you would write in PyCaret. So you can see by the time you finish your experiment and you're doing diagnostic or model plotting, you write 23 lines in PyCaret and you write 170 lines in scikit-learn. The point here is not to reduce the lines literally, but if you're writing less lines, that means you're saving time. That's the point. And this is also the productivity gain. This is in terms of time. So on your left axis is the percentage of time taken when PyCaret is used, and on your x-axis, these are units. So units is a set of tasks. So unit 1 is easier than unit 2. Unit 2 is easier than unit 3. So it's as we increase the unit, we increase the difficulty. And you could see that in a supervised experiment, in doing the hardest job in a set environment that we have experimented, you would take only 8% of the time that you would take you would take only 8% of the time that you have taken in scikit-learn, you would take that 8% PyCaret. So it's a huge jump. Okay, some facts about the project. So it started last year, as I mentioned, when I was going through my school. It started in the summer of 2019. It's completely written in Python, no bindings for any other language at the moment, but future versions may include wrappers in other languages, thin wrappers. No promises, but there is a good chance that will extend this to other environments. Project took approximately 1 year to complete, and it's fully self-funded so far. And it's supported by a team of brilliant people, mostly students from Queen's University. And if you are interested and would like to contribute to this project, this is the link. You can fill up a small form there, and it would be good to see contributions coming from community. Okay, who should use PyCaret? So data scientists who wants to increase their productivity, all it does at the end of the day is saves you some time that you can refocus in somewhere else, or maybe investigating or scratching the surface of business instead of learning how to troubleshoot a code. Okay, consultants, data science teams for rapid prototyping and proof of concept projects, and obviously students with no background in computer science. And one more point is students or anybody who's transitioning from R to Python. I think it's the API of PyCaret is more like R style, so it's very easy to do that transition if you're looking for one to transition from R to Python, or not just transition, but generally if you want to start with Python and you've not done it before and you have some experience in R, then this becomes easier because the API resembles a lot. All right, and we have also seen PyCaret being used on Kaggle in competitions. So these are our numbers for last 30 days. We have reached over 700,000 people. That translated into 80,000 downloads, and we have a very active community and community of readers on Medium. So you should check out the articles if you like reading. Okay, and before we get into the demo, last thing is PyCaret 2.0 is coming. PyCaret 2.0 is a command line driven end-to-end machine learning tool. That means you can, at the moment, you can use PyCaret mostly in the notebook environment like Jupyter Notebook or Google Colab or Jupyter Hub. But after the 1.0 release, we didn't realize there's still a lot of data scientists who are training the models on command line or using Spider or any other IDE that doesn't support HTML. So 1.0 wouldn't work in those environments because you're heavily using HTML to show a few things while you're performing your experiment. I'll show you in a while. But 2.0 would have a command line support. So that means that when you initiate PyCaret, you would be able to set the HTML parameter as false to work with command line software. That just extends the power to all the software that has a Python interpreter. So for example, you could write PyCaret code in Tableau, in Power BI, in Alteryx, in Nine, anywhere that supports Python command line, which is almost every tool these days. PyCaret 2.0 would be bigger than just a library because it would be a complete end-to-end model management tool. And in order to achieve that, we have integrated PyCaret with MLflow. So the backend of the entire library would be automatically designed in MLflow. And as a user, you would just get a nice, sweet, and functional user interface to work with. And this release is coming in next 30 to 35 days. So we are very close. And one more big thing for next release is, it's not I mean, many people, if you have heard about PyCaret before, you must have seen that it's an automated AutoML, but it is not AutoML. This is a modular AutoML. And I'm going to talk about that a little while towards the end. It's not AutoML, but you can use this library to construct your own AutoML. And the last part is we would have a native support for Databricks in our next release. As you know, Databricks is tightly integrated with MLflow. It's the same company. So, all right. Okay, as for demo, if you are planning to follow along on your own computer in Jupyter Notebook, then you can clone this repository here and install PyCaret, pip install PyCaret. And if you're using Mac operating system, you might have to download LightGBM separately and build it from source. The instructions are on our install page. You can follow that. And if you don't want to follow locally, you can go to this link, pycaret.org/demo. And there are 4 links for 4 Google Colab notebooks because there are 4 demos, one for classification, one for regression, one for clustering, and one for NLP. And we will see if we can cover all of them. Okay, I'll give 1 minute here for people who are trying to follow together. I'll give 1 minute here for them to, all right. So let's get going. I would switch my screen to my Jupyter Notebook. locally. And the first tutorial that we're going to follow is, first demo is PyCaret classification. Um, Let me zoom into my screen. I hope everybody can see this now. Okay, let me import. So I have already installed PyCaret in my local computer. Let me start by checking. It's a version 1.0.0. Let me get the data set. So you don't have any CSV files for this demo because we have a repository on our PyCaret GitHub page, and you can get the data directly from the repo as long as you have internet. So I'm using a data set called Juice for this demo. And what this data set is, each row in this data set is a transaction of what kind of juice a customer has bought. So there are two types of juices, CH and MM. I guess MM is Minute Maid and CH is something. So each row is a transaction, and we have to build train a model that could predict, given all these factors, the customer would buy which juice. And the factors are price of both the juices, the discount on that day of transaction, sale price, and which store it was bought in, and list price differences, blah, 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 right? So all these features. And our target variable is purchase, of course. Okay, setting up. So PyCaret has 6 modules: classification that supports binary and multinomial classification, regression, clustering, unsupervised, anomaly detection, unsupervised, NLP, and association rule mining. And the real power is all of them works exactly the same way. So you don't have to remember code, because as I go through this notebook, you would realize that there's nothing to code, because these words are natural constructs: set up, compare, create, just like in SQL. You don't have to remember it, right? And because you can use the exact same language or consistency of API across the 6 modules, and obviously when we'll have time series module, same goes there. That makes it powerful, because you really don't have to worry about anything. You would just open a new notebook every time from scratch and just rather write the line yourself instead of opening up a link, copying the code, worrying about maintaining the code, because you don't want to do that. So you can just write this on fly, right? Okay. Every experiment in PyCaret in any module starts with setting up the environment. And what happened when you set up the environment is we do bunch of activities behind the scene. In case of supervised experiment or classification specifically, all the pre-processing is done when you set up any experiment. And how to set up, you just pass your data frame, which is this. Data is equal to get data juice, and then you pass the name of target variable. Session ID for now, just assume this is a seed, a pseudo number generated that would be distributed in all the functions that you would perform today in PyCaret in this session, right? And in addition to, so this is the simplest way of setting up anything in PyCaret. You just pass the data and target. In case of unsupervised experiment like clustering or anomaly, you even don't pass target, you just pass the data, right? And let me run this and show you what happens. So the first thing is it would print a grid that these are the data types that we have detected. If they are not right, type quit to exit, otherwise press enter. And it would basically by default try to infer the data types of each variable, because as I said earlier, there's a difference on how you would treat a numeric variable or a categorical variable in machine learning, right? So this is a very important step. Although 80 to 85% of the time this is right. So in this case, for example, this has detected that this is an ID column. I will drop it. You don't need to drop it from your original source data set. PyCaret would internally hide this column before training a model. But when it returns the result to you, it would still be attached, so that you don't have to do that piece, drop and reattach or reappend, right? And for rest of the features, if it detects the date time variable, it would create a feature from date time, like year, month, and all those time series features, and would drop the date itself, because you don't use date as is in machine learning. So if there is a date, we'll extract the features. Apart from that, I think everything is fine at this point. Let's assume it's fine. I'll press enter, and it would print this success message for me and a grid. And grid would give a couple of things. So it would say session ID 786, which is seed. This is like a unique ID. You remember this is not 1 or 0, right? So we need a label encoding to work with this. So it would do the label encoding and give you the legend here, and print bunch of pre-processing information, such as how many were numeric features, categorical features, um, numeric, what kind of imputation you did you do normalization, in this case false, transformation, PCA, ignore low variance, combine wear levels, remove multicollinearity, numeric binning. So all those 20, 25, 30 basic common techniques in machine learning, you can control that from setup. And if I show you the documentation here, let me make it bigger. Okay, so all these functions, and they are more like a switch for you. So for example, in this case, we haven't done any normalization, but if you were to do normalization, you would just pass normalize is equal to true, and then you can select 4 or 5 methods, and you can select methods as well. All right, same goes for transformation, PCA, or any other pre-processing technique. It also uses some of the unsupervised techniques, such as create clusters. So that means it would iterate over the data set, find the ideal number of clusters where there are 2 metrics that it would try to optimize together, and based on that final model, it would create a label column in your data set using an unsupervised k-means model, right? So there is quite a few options there. All right. Okay, so once the setup is done based on any pre-processing or no pre-processing at all, in this case, you can start with doing baseline models. And the way you do it, you just type compare underscore models, and it's very, very obvious, right? And once you enter, what it would do is it would train all the models in model library using 10-fold cross validation. And these are the metrics based on average metrics based on 10-fold cross validation, right? Accuracy, AUC, recall, precision, and kappa. Very, very common metrics in case of classification. In next release, we are adding 1 or 2 more metric in this grid, and we can continue to add as many as we want. And this is not just all the scikit-learn models, but we are also, because we're small, we are architecturally very flexible. So we have this opportunity to integrate more and more models into a sklearn style API, right? So we already have like GBM, XGBoost, and CatBoost, but nothing is stopping us to include younger algorithms, right? Because it's a long process to get an algorithm entered into a scikit-learn ecosystem. There's a requirement that you have to have a couple of citations and number of years, but we have this flexibility to include those algorithms, whether you want to use them or not, that's totally up to you, but we can at least compile them under one hood. All right, so the compare models function has returned you the entire table. In this case, these are 15 models and their metrics. This gives you a starting point. From here, you can pick a specific models, top 3, and work with them, try to tune them, ensemble them, blend them, or do whatever you want to arrive at a final model, right? And there are a bunch of parameters that you can pass under compare models. You can change the number of fold to 5, change the round value, which means the precision that you see here, to a different number. You can change the sort parameter. So by default, table is sorted by accuracy. You can change it to recall, precision, F1. So if you're sorted by recall, QDA would come on top instead of logistic regression. All right. So this is the starting point. And now that I know logistic regression is doing really good, and I know this data set that logistic regression is doing very good, I can create logistic regression 10-fold using create underscore model. Simple. And what it would do this time, it would print all the folds in front of me and the average score. And this would basically match with what we have seen in the table above, 8302, 8302, right? And if you want to change, you want to do a 5-fold validation, you can just pass fold is equal to 5. You have a 5-fold validation, right? So very easy. Similarly, and also these initials, if you see the Docker string, you would see a table here. If you have to do logistic regression, pass LR, KNN, knife base. So this is also very intuitive. It's not that you have to remember it, because as long as you know what you're doing, it's very intuitive. It would occur naturally to you. So if you want to do a decision tree, it's very obvious it would be DT, right? So this is decision tree tenfold. So as create is for creating a model, tune is for tuning a model, tune underscore model, just pass DT. And there's a random grid search sitting behind the scene. It would iterate over the random grid search and return you a model. In this case, we have a tuned decision tree model of performing with 80% average accuracy compared to 75% when it was printed with default parameters, right? Okay. Similarly, you want to tune knife base, so NB for knife base, and by default, it would optimize accuracy function with the number of iterations is equal to 10. But if you want to change that, you can do this: tune model, knife base, optimize AUC, and iterate 20 times, right? So it would iterate 20 times and then bring the best model out. And the model that you get is basically nothing but a scikit-learn estimator that you can use all the original attributes and parameters if you want. So if you want to see, right, so you can see the predict proba and predict log proba. This is still available, right? But PyCaret has its own native predict model function. What it does is it applies the entire processing pipeline, not just the model, because you don't need just the model. You need all the pre-processing in terms of normalization, transformation, creating new features, clustering. You need everything, right? So PyCaret's native functionality of predict underscore model binds everything together. So it's a huge pipeline with all the pre-processing that you have done. And the last object is a model, which is this model, right? And we'll see that. How does that work? Okay, so we have seen compare, create, tune, and for ensemble, very intuitive. Ensemble underscore model DT. By default, it would use bagging. So if you would see this model, let me rerun it again. If you see this model, this is a decision tree wrapped inside a bagging classifier. See that bagging classifier, base estimator decision tree. You can also boost it by wrapping it under add a boost. So boosted DT. So you just have to pass method is equal to boosting. And by now, I think it's very obvious that it's really simple and it's really, really concise. Anyways, you can also blend a couple of models together. So in this case, if you notice what I'm doing is I am creating 3 models. LR is for logistic regression, LDA is for linear discriminant analysis, and GBC is for gradient boosting classifier. And I'm passing verbose is equal to false because I don't want this information grid to be flooding over my screen. So let me just save it. Okay, so now I have 3 models stored in these variables. What I can do is I can create a voting classifier. So blend models and just pass these 3 models. And you can pass methods soft or hard. Soft would mean that it would use the probability values. Hard would mean it would use the label to create a voting classifier. You can see that these are the estimators. What you can also do, there's a bunch of plotting available, and you would see it saves you a lot of time. You'll see that. So in order to plot anything, plot underscore model, and you just pass your model. By default, it gives you a AUC plot in classification and error plot in regression. But there are a bunch of options. So if you go shift tab, there's again a table, and you can do all these plots here, right? There are 14 or 15 of them. Let me just print them all together. Zoom out. So AUC, confusion matrix, threshold. Okay, so threshold plot, precision recall curve, validation curve, boundary plot. So this gives you an ability to do it really quickly, right? So I have in just like 3 lines and like less than 10 seconds, I have seen a decision boundary of my normal decision tree, and you can see it here. Looks like an overfit, pretty obvious, common with decision trees. This is my knife-based decision boundary, and this is my blender boundary. Is very brutal. Anyways, and you can also use evaluate model, which kind of prints this small, nice little widget for you. It does the same thing. It calls plot underscore model under the hood. So you can select AUC, precision recall, error, class reports, so like that, right? We also have implemented Shapley values through a Shap package in Python. If you don't know what is Shapley value, you should read about it. It's pretty useful for model agnostic. What it does is I'm creating an XGBoost model here and passing it under interpret model function. And what it would do is return me a Shapley plot, a model agnostic plot at a model level, right? I'm not going to go into how to read this plot. There's a bit of learning curve because it is plotting three dimensions together. So there is a learning curve, but I encourage you to read it at your own time. Very useful technique. And also, if you work if you work in a regulatory environment and you are using machine learning, you would understand there's something called reason code. That means if you are using a model in bank and that is predicting a customer outcome, you also have to provide reasons to customer. So you can also query your model at an observation level. So in this case, I am querying my trained model to give a reason plot for observation 1, which means whatever the transaction in my test set number 1. This is that, and you can see the features that are contributing against a particular type of juice and features that are contributing in favor of particular kind of juice, and these are additive. So it's very useful for analysis. And you can have a overall plot, which is interactive. So I think once you go through that learning curve and understand, you would find this useful to do controlling and effects, but purely for analysis purpose. All right. So this was classification. Let's move to a notebook for regression that I prepared. Same thing. I will check the version, and this time I'm using this data set for regression, right? And this data set is each row is a diamond, and based on these factors like weight, cut, color, clarity, polish, symmetry, and report, we have to predict the price of diamond. This is a very famous case study for Darden Business School. It's called Sarah Gets a Diamond. And this data set is, just a training set of that case study. What I'm going to do today is build a regressor to predict the price of the diamond given all the other factors. And you can see no difference at all, except that instead of classification, I'm now calling my regression module. Everything else being same, shift enter, same experience, exact same experience. And this is not a coincidence. This is very intentional that it should be exact same experience. And you can see, I will press enter, same grid is printed because it's almost the same pre-processing features that you would apply. In this case, I am again running all the models. In this case, I'm blocking certain models. So Thielsen regression, Cat boost, and random consensus. I'm blocking them for this run in the interest of time, but let me run it. So what it would do is it would not train these 3 models. But it would train, and there are quite a few regression models. And notice that I haven't done any pre-processing here, right? It's just plain vanilla models. So there are few things in pre-processing that we would do by default, because if we don't do that, you won't be able to train your model. So for example, if there's a missing value in your data set, we would impute it by using a default method. If there is a categorical variable, like in this case, clarity and polish, we would do one hot encoding by default, but there are other encodings available. You can use them, but by default, we'll do it so that we can at least train the models, right? So while this is going on, and in case of regression, you can see again 6 common metrics: my MAE, MSE, RMSE, R square. RMSLE and MAPE not kind of speak about specifically about them, but we're very popular on Kaggle. And Kaggle was my reason I added RMSLE into this. Okay, it might take 1 more minute. I think it's 12:43. I think we are good with time. We'll be able to see clustering and NLP very quickly, and then let's try to leave. Uh, let's try to end it at 12:55 so that we have time for questions. Okay, so this is the grid. In this case, you can see extra trees regressor is definitely performing the best. I have a starting point, but what I want to show you here is so the original challenge of this case study was to build a linear model. And in this case, you can see, if you see my linear regression model, it's on number 11 and it's 85% R square compared to 97% for the top model. So I have to now work with linear regression model, but since there's a big gap between what's the linear regression performance versus the best model, as a data scientist, I'm expected to elevate the performance of linear model, right? And in order to do that, there's only really one way, is to analyze the data, do EDA, understand why this is not performing. Is it not meeting certain assumptions for linearity, or can I do anything with it to make it work with linear algorithms? And I can show you, if I do a linear regression, 85%, the result is same as here, because it's the same thing. And let me show you this plot. And if you recognize this plot, this is a heteroscedasticity, and you can see there is a pattern in it. It shouldn't be like this. And if you remember, this is the problem with the linear model. And the reason this is a problem is because the data didn't have linearity. So it has to be transformed in a way. And I'll show you, let me show you this Panda. So if you pass profile is equal to true, you get a pandas profiler with a get data function. And I'm doing this so that I can show you why it didn't work and how can we fix that. Okay, so this is my profile. This is my target variable, and this is the histogram. Not linear at all. And we were assuming like linear algorithms had several assumptions about linearity. So very obvious why this is not working, but we can fix this. We can fix this. And you can also see caret weight. Looks like almost a categorical variable, because you can see there is a natural breaks in the distribution, right? Maybe converting this variable into bins into categorical variable by binning them would be a good idea, and we can try that. So this time I'm passing a setup with pre-processing options, right? So I'm passing my data, target, these three variables, these three parameters are same as above, but this time I'm transforming my target variable. By default it uses Yo Johnson, but you have two other options that you can use. I'm binning my numeric feature, caret weight. We have seen this histogram here. We are binning it. It uses Sturge rule for binning. And if you don't know, I encourage you to read about Sturge rule. And I'm asking to remove multicollinearity because linear algorithms, you want to get rid of multicollinearity for them to work. And feature interaction true. So I'm also creating a lot of features by multiplication and dividing, right? So I pass feature interaction is equal to true. Let's run this. First thing you get is the same confirmation. Everything is okay. You press enter. So it is doing what it is doing behind the scene. It is constructing the pipeline, and you can see this time. So if you would see, your original data set had 7 columns, 6 features and 1 target. And after transformation, there were 28 columns, obviously, because we have applied one hot encoding on these categorical factors and it became 28. But this time in the second run I did, we have 65 columns to work with. And the reason we have 65 is because we have created new features on the fly using this feature interaction flag. And if you see the documentation, you can set the threshold and you can set degrees and a bunch of other options, but you can read the documentation, very straightforward. But the point is we have used this feature here to create new features. But the problem is our data set originally, and will still have only 6 features, right? But these features were created on the fly. So you need to have a pipeline orchestrated in sequence that would replicate the exact same thing. So when you deploy this model, you would still get from your upstream system, you would still get 6 features. You need a pipeline sequentially orchestrated that would perform all these steps, and you would end up getting a 65 column data set before you actually pass it to dot predict in case of scikit-learn, right? But here the power is, okay, before we get into the pipeline thing, let me just quickly show you. This time I'm not going to run compare model. I just want to show you the improvement on linear model. So let me just run LR. And you can see my LR with this pre-processing is now bumped to 95% in R square. And if you will see the plot now, you can see that residuals are now approximately normally distributed, right? And we have that pattern of heteroscedasticity is gone. Error is also plot, and then, okay. You can, I'm gonna skip this part. You can use it for predict, and obviously, as I mentioned earlier, predict underscore model is a native functionality. So native to PyCaret, that means when you use this, you don't need to worry about the transformation pipeline. It would apply everything in sequence and then predict the model. But let me show you something. So let me run this code and let me finalize my linear regression model, and I've stored it under final LR, and let me save that. So when you save it using save underscore model, you get this message. And now if I load that, you can see if I print this, see this. It's a complete pipeline. It's not just model, and the last object of pipeline is a model. But first is the entire pipeline in sequence, right? So it's a big time saver. There's another functionality in this is you can directly deploy a model from your notebook into your AWS S3. And for future release, we're gonna support Google as well as Azure. But for now, you can just write this code, deploy underscore model, and type your platform and your bucket name, and you can just push the model directly to S3. I'm not going to run this cell now. It takes 1 or 1.5 minutes, but you can try that. You need to have an AWS CLI on your computer in order to do that. Okay, clustering, same concept, everything same. I'm getting this data. This data is basically a bunch of economic variables by country. So there's a country column, and then exports, health, imports, income, inflation, blah, blah, right? And there are about 200 countries or so. Exact same method, PyCaret.clustering. Now you set up, and this time I want to normalize my data because, you know, for k-means, you need to have that, the scale has to be same. And at this time, the scale is really different if you see income column versus the other columns. So I'm normalizing it. I'm also ignoring country features. So that means that I'm telling PyCaret that when you're training a model, don't look at a country column. Alternately, in absence of this, what you would do is you would drop the column, train the model, attach the column back, attach the label. In this case, you're just telling PyCaret, ignore it. So you don't need to drop it. So the power for this is you can really use this in any of your downstream system, right? For example, you can put this, inject it in your Power Query code, and you don't want to change your pipeline that is throwing a table because there are other processes or tools or that are using those columns. So for example, if there is a dashboard in Power BI, you don't want to drop the country column because that is using. So what you can do is on the fly, you can just ignore it, right? Then again, to train a model, you just do create model, this case, k-means. Oops, I've not run this cell, sorry. So it would do the exact same thing. It would run the setup. It would first ask you for confirmation for all these variables. I would say yes. It would go ahead, print this grid, and then I can train my models, and you can see the objects that you get is a scikit-learn estimators. For clustering, it becomes more powerful. I mean, there are a bunch of plots in classification and regression, but for clustering, it becomes more powerful to have these interactive plots. So in this case, I am plotting my k-mean strain model in this plot with the country as a label. So if you remember, if we would have dropped country column, this plot was not possible, but this is also like we have done PCA under the hood to plot all these countries. If you were to do your plot, you were to do this plot by yourself, I mean, it would take a couple of lines of code and some time to do this. Okay, I think my notebook is frozen. Okay. All right, so a few other plots. So this one is in the three-dimensional Disney plot, elbow, silhouette, and the distribution plot, which is probably the most useful because at the end of the day, when you're doing clusters, you want to see the differences in feature of distribution by clusters. So that's what it is. Same thing, you can assign the labels. So just with this code assign model, you get your original data set back with a cluster column. And if you have noticed, we haven't changed any of the numbers here. So the output is still human readable. And that's what business need. If you're not using PyCaret and you're using just raw low-level libraries, you would get a NumPy back, you would convert into frame, you would attach the data back, and also you'd have to use the original data because otherwise, if you use the scale or transform data, that's not a human readable output, right? But we handle that in here. All right, and the last thing is NLP. Just to show you, I've already executed this notebook, so I don't need to run it, but just to show you exact same thing. In this case, I have a data set with a bunch of columns, and one of the column has a text in it. It's a loan application. And you can see this is what it looks like. I'm setting up environment, passing a column with the text, and it would handle all the text pre-processing under the hood. So tokenizing, bigram extraction, trigram extraction, or any kind of encoding. It would handle about 13 to 14 by default methods that it would use before you would train a model on it. And then if you want to create a topic model, you can create a topic model by create_model LD, right? Very simple. If you want to create a non-negative metric factorization model, create model NMF. So really simple. For NLP, there are quite a plots. For NLP, the plots are interactive too. So this is the distribution of all the words in this corpus, bigram. This is my topic segregation. After training an LDA model, this is a Disney plot. And the way I got it is just by writing plot model, plot Disney, right? Really powerful. Again, so the same concept. You also have this evaluate model where you can just select and run. It's the same thing as if you were to do plot by yourself. Right, and I think that brings me to the end of 4 demos. Let's get into Q&A. I'm trying to figure out how to. Where do I see questions?
Hey, Moez, all the questions are in the chat. So if you just want to hover over the bottom half of your screen, you'll see an option for chat. Inside of your Zoom, sorry. Yeah, so if you just want to go back to your Zoom.
Oh, here. Okay, so this is it. How do we get the slides? So slides are uploaded on the GitHub repo. And let me type that repo here. You're right, because the link is in the presentation. Right, so you can see the PPT is here, so you can get the slides from there. Does PyCaret consider hyperparameter for each algorithm? Because I'm seeing that you just call the ML algorithm and that's it from what? Yeah. So, for whatever the models we have in our zoo or model library, we have a defined tuning grid for each parameter under each model. In next release, we are giving a flexibility to pass a custom grid. So if you want to create a light GBM, just by iterating over learning rate from 0 to 1, and iterate 50 times randomly, you can do that. At the moment, it would use our own predefined grid, which is quite a research, but you can pass a custom grid in the next release. But yes, even in this release, for each algorithm, it has a separate tuning grid. Do we have access to internal details of each step in PyCaret pipeline? Yeah. So I think it returns you the pipeline object when you save it, and then it's basically a object called pipeline from scikit-learn. So you can do whatever you would normally do with any pipeline in a similar way. Can you change any of these steps? Yeah, you can. There is some level of flexibility. So for example, when you're doing feature interaction, you can pass the interaction threshold that would determine how many new features or how many less features it would create. It has flexibility to some degree, but obviously with any solution, as you try to standardize it, there's always a trade-off between flexibility and complexity, right? What customized data normalization and transformation be supported in an environment? How can we access that? Well, no, there's no, so you cannot have a customized transformation or encoding in setup at the moment, but seems like a good idea. Does PyCaret use scikit-learn under the hood? Yeah, so PyCaret integrates about scikit-learn along with other libraries like LightGBM, K-modes, and CatBoost, XGBoost. So it has scikit-learn as one of the library. Is this being used in the field? Have any companies been using this? This is more for proof of concept, not necessarily high-grade production projects. But yeah, from my limited knowledge about who is using PyCaret, I think mostly consultants or boutique consultants who are doing proof of concept projects in data science, they're using it. How the cluster number is chosen. So it basically tries to optimize to unsupervised metric, and at that point, whatever the best number of clusters is returned, it would use that to create that number of clusters using k-means. Can you use PyCaret on parallel? Yeah, you can do parallel, not distributed processing. That means you can use njobs equivalent parameter of scikit-learn, but it's not like a Spark. It's not distributed. I think if we don't have any more questions coming, we can, let's give it a minute. Impressive work. Can you use it on, thank you. Can you use it on GCP? Yeah. So there is so if you would see in the slide, there is a deploying tutorial on Google Kubernetes Engine. And I think I would point out one thing for here. All the material that we create, tutorials, video tutorials, or anything, they are extremely basic and beginner. So when I write deploy machine learning pipeline on Google Kubernetes Engine, that tutorial is that read is like 12-minute article, but it assumes that a reader absolutely knows nothing. He doesn't know what is Docker. He doesn't know what is container. He doesn't know what is Kubernetes. He doesn't know what is GCP. So I encourage you, if you haven't done that yet, then these are really great resources for you. And to answer the question, in this tutorial, we have shown how to create a pipeline, develop a pipeline using PyCaret, put a Flask app on top of that, and then launch it into GCP using Kubernetes. Some more questions. Plan of support for DAS in near future. Nothing at this point. We have quite a few. We have quite a few upgrades coming in the next release. The biggest one being the ML flow support, because that is basically taking this entire thing to next level. Because you can run you can not only run multiple models, but you can log multiple pipelines. That means you can have 300 models with different pipelines, different configurations in one file, and it would be like a leaderboard, functional leaderboard. So I think that's quite some work there. But Dask is definitely very exciting. So if anybody of you have a feature request, the way we are handling it is just open up an issue on our GitHub page, and somebody would talk to you and then understand the user story from you and tag that as enhancement. And we have a team that is prioritizing the features and actively working to release those features. So so we have released PyCaret 1.0 on April 19th, I believe. And in last 50 or 55 days, we have over 235 commits. So we are very actively working on this. Thank you. Thank you that's definitely a great suggestion. And I know there are a couple of implementations in Python that does that already. So great. Last question, TensorFlow support. So this is still very debatable in our team, that whether we should extend it to include deep learning frameworks like TensorFlow or PyTorch. At this moment, we are not sure if that's the direction we want to go in. Deep learning is its own entire world, and I think we should leave it for now because we have bunch of things, low-hanging fruits that we can go after. So for example, we can go after time series, which is already somebody is already designing it as we are talking. So time series is there, Markov chain is there. There are a bunch of things that we can do in the area of canonical machine learning before moving into deep learning. And I think it would be really difficult to reparize deep learning. All right.
Awesome. Thank you so much, Moez. Such a great presentation. I just want to let everyone know that once again, all the content is being recorded and will be shared. We look forward to hosting you just in a couple of days. You will be receiving an email for Hopin. Once again, that's our platform that will be hosting all the talks. So once again, thank you for attending this workshop, and we will all see you tomorrow. Thank you.
Thank you, everyone. Thanks for us. Bye.